Welcome back to my YouTube channel Sriram Devarajan. Today I am going to discuss some other problem from KSET 2013 Mathematical Science question paper. I am going to discuss problem one by one, starting with the first problem. Let T maps U to V be a surjective linear mapping and dimension of U is 6, dimension of V is 3, then option A, dimension of kernel of T greater than 4, option B, dimension of kernel of T equal to 4, option C, dimension of kernel of T greater than 3, option D, dimension of kernel of T which is equivalent to 3. Here in this problem, T is given as a surjective linear map from U to V with the dimension of U is 6 and dimension of V is 3. Then we have to check which option is the correct option for this surjective linear mapping problem. Since T is surjective means onto. Solution: since T is surjective means onto, injective means 1 1, bijective means 1 1 onto. T is onto. We know very well, if F is onto, range of F is V. If map F is onto map, then range of F which is equivalent to V. Here range of F is T of U which is equivalent to V, dimension of T of U which is equivalent to dimension of V. Dimension of T of U means rank of T which is equal to dimension of V. Dimension of V is given as 3. Rank of T 3. But we have to find the dimension of kernel of T. From all the options, we have to check dimension of kernel of T is equal to 4 or equal to 3 or greater than 4 or greater than 3. By rank nullity theorem, rank of T plus nullity of T which is equivalent to dimension of domain space, that is U, which is equivalent to 6. Rank of T is 3, nullity of T is 6. Rank of T plus nullity of T equal to 6 means 3 plus nullity of T equal to 6. Nullity of T equal to 3. Nullity of T is 3 means dimension of kernel of T. For this problem, option D is the correct option. Dimension of kernel of T is 3, that is nullity of T is 3. Second problem. if is a n-dimensional vector space and T is a linear transformation on V such that rank of T nullity of T are identical, then n is even, which is option A. Option B, n is odd. Option C, dimension of V which is equal to three into rank of T. Option D, n equal to 5 into rank of T. Here in this problem V is given as n-dimensional vector space and T is a map which is a linear transformation. Linear transformation means T maps from V to V such that the condition is given rank of T equal to nullity of T, then which of the option is the correct one? N is even, n is odd, dimension of V is 3 times rank of T, n equal to 5 times rank of T. Solution: V is n-dimensional vector space, therefore dimension of V equal to n. It is given. T is linear map, that is V to V, and also given rank of T equal to nullity of T. By rank nullity theorem, rank of T plus nullity of T, dimension of dimension space, that is dimension of V which is equal to n. Here rank of T is equal to nullity of T, rank of T plus rank of T is n, 2 times rank of T n, rank of T which is equal to n by 2. This n must be even. If it is even, we may get the answer as some integer value. If n is odd, we may get fractional value. Rank of T should not be a fraction value, it must be some integer value. For this rank of T, this n should be even, then only we find rank of T which is a integer. If we choose n is odd, we may get fractional value. Rank of T never should be a fractional one. Therefore for this problem option A is the correct option, n is even. Now I am going to discuss the third one. Let T maps from r power 6 to r power 6 being a linear mapping such that t square equal to 0, then Option A, rank of t less than or equal to 3. Option B, rank of t greater than 3. Option C, rank of t equal to 5. Option D, rank of t which is equivalent to 6. Here in this problem, t maps from r power 6 to r power 6 be a linear mapping such that t square equal to 0. We have to find the rank of t, whether it is less than or equal to 3 or greater than 3 or equal to 5 or equal to 6. Solution. We know rank of AB which is greater than or equal to rank of A plus rank of B minus n. Here if you choose A equal to B which is equal to t, it becomes rank of t square greater than or equal to rank of t plus rank of t minus n. A dimension is 6. Rank of t square is 0 because t square is 0. 0 greater than or equal to 2 times rank of t minus 6. 6 greater than or equal to 2 times rank of t. 3 greater than equal to rank of t. Rank of t less than or equal to 3. For this problem, first option is the correct option. Now I am going to discuss the problem fourth one. The value of the integral over c dz by z square plus 9 where c is the ellipse, x square by 4 plus y square by 1 which is equal to 1 and the integral is taken in positive sense is option A 0, option B 2 pi I, option C pi I, option D minus 2 pi I. Here the problem is from complex analysis. We have to find the integral value over c dz by z square plus 9 where c is nothing but ellipse. Ellipse equation is given as x square by 4 plus y square by 1 equal to 1. Whether the value for the integral is option 0, second one 2 pi I, third one pi I, last one minus 2 pi I. First of all, Find the points to draw the ellipse. If you take y as 0, x square must be 4, x equal to plus or minus 2. If you take x as 0, y square equal to 1, y equal to plus or minus 1. Now the ellipse x value plus or minus 2. This is 2, 0. This is minus 2, 0. This is 1, 0. This is minus 1, 0. The ellipse is look like this. Here, to find the pole, equate the denominator to 0. That is z square plus 9 equal to 0. Z square is minus 9. Z equal to plus or minus 3i. Here points are 0, 3 and 0, minus 3. Both the points lie outside the ellipse. By Cauchy residue theorem, integral over C f of z dz is nothing but 2 pi into sum of the residue. Since both the points lie outside the ellipse, therefore residue is equivalent to 0. Therefore integral over C f of z dz 2 pi into 0, which is equivalent to 0. For this problem, option A is the correct option. Now I am going to discuss the problem, fifth one. The value of lambda for which y of x equal to 1 plus lambda x is a solution of the integral equation x equal to integral 0 to x e power x minus t y of t dt is first option, lambda equal to 1. Second option, lambda equal to minus 1. Third option, lambda equal to 0. Last option, lambda equal to 2. We have to find the value for lambda, for which y of x is given as 1 plus lambda x. The integral equation is given as x equal to integral 0 to x e power x minus t y of t dt. Solution. given integral equation is Volterra because upper limit is variable x. If both the limits are constant, then we can say the integral equation is spread down. What is given? X, which is equivalent to integral 0 to x e power x minus t y of t dt. I am going to apply DUIS. DUIS means differentiation under integral sign, or otherwise we call it as Leibniz rule. 1, which is equivalent to integral 0 to x e power x minus t y of t dt plus e power x minus x y of x d by dx of x minus e power x minus 0 y of 0 d by dx of 0 is 0. 1, which is equivalent to this part is nothing but star, that is star means x. 1 plus x e power 0 y of x d by dx of x is 1. 1 x plus y of x. What is y of x? Y of x is 1 minus x. If you compare this 1 with y of x, which is equal to 1 plus lambda x, we get lambda is minus 1. For this problem, lambda is minus 1 is the sixth sum. Limit x tends to pi by 2 1 plus cos x power tan x. Option A E, option B 1 by E, option C 0, option D 2. The problem is given as limit x tends to pi by 2 1 plus cos x power tan x. Solution: limit x tends to pi by 2 1 plus cos x power tan x. If you substitute x, if you substitute x equal to pi by 2, this part becomes 0, this part becomes infinity. It is of the form 1 power infinity. For the problem which is of the form 1 power infinity, write e power limit x tends to pi by 2 f of x into g of x. If you take this one as some f of x, this one as g of x, we can write f of x into g of x e power limit x tends to pi by 2 cos x. Here g of x is tan x. Tan x we may write it as sin x by cos x. Cos will get cancelled. E power limit x tends to pi by 2 sin x means e power sin pi by 2 e power 1, which is equal to e. For this problem, option A is the correct option. totally we have solved and discussed 6 problems. Now I'm going for the seventh sum. Limit n tends to infinity 1 minus 1 by 2n power n plus 1. The same method what we have applied in the problem number 6, we are going to apply the same method. See, this term must be 0 if you substitute limit n tends to infinity. This term becomes infinity, this term becomes 0. It is of the form 1 power infinity e power limit n tends to infinity 1 by 2n into n plus 1, that is e power limit n tends to infinity n plus 1 by 2n, which is e power limit n tends to infinity, take n outside, n into 1 plus 1 by n by 2n. This n will get cancelled, which is equal to e power, if n approaches infinity, this term must be 0, e power minus 1 by 2, 1 by e power 1 by 2, 1 by root e. I am write the options. First option root e, second option 1 by root e, third option 0, fourth option 1 by e. For this problem, B option is the correct option. Now I am going to discuss eighth integral 0 to 2 pi e power I theta d theta, option A 2 pi, option B 2 pi I, option C pi I, option D pi. We have to find the value for the integral 0 to 2 pi e power I theta d theta. From the 4 options, which one among the 4 options is the correct one? We have to find out value for the integral, which is 2 pi I, whether it is pi I or pi. Solution. Let e power I theta, which is equivalent to z, mod z equivalent to 1. Since modulus of e power I theta means square root of cos square theta plus sin square theta, square root of cos square plus sin square 1, square root of 1 is 1. E power theta, if we take it as z, mod z value is 1. dz by d theta, which is equivalent to e power I theta into I, which is implies dz equal to I e power I theta d theta I z d theta. What is d theta? dz by Iz. Therefore, integral 0 to 2 pi becomes integral mod z equal to 1 e power z d theta means dz by iz, which is equal to 1 by I integral mod z equal to 1 e power z by z dz, which is equal to 1 by I integral mod z equal to 1 e power z minus 0 into dz. Clearly, 0 is the only one pole that lies inside the circle mod z equal to 1. By Cauchy integral formula, 1 by I 2 pi I into f of 0. Since z equal to 0 is the only one pole. By Cauchy integral formula, we know very well integral dz, integral f of z dz by z minus a 2 pi I f of a. Here a is 0. F of z is e power z. One by I 2 pi f of 0 f of z equal to e power z, f of 0 e power 0, I cancel, e power 0 is 1, answer is 2 pi. For this problem, option first one is the correct one. Ninth sum. Let A be a 3 cross 3 matrix with eigenvalue 2, 3, minus 1 and B equal to A square plus A. Then determinant of B equal to 1, first option 0, second option minus 6, third option minus 2, fourth option 144. Here matrix A is given as 3 cross 3. Therefore 3 eigenvalue. First eigenvalue 2, second eigenvalue 3, third eigenvalue minus 1. And B is given as A square plus A. We have to find determinant of B. Solution. Lambda 1 is 2, lambda 2 is 3, lambda 3 is minus 1 is the eigenvalue of matrix A. Since B is A square plus A, For lambda 1 2, what is B? If lambda is eigenvalue of A, lambda power n is eigenvalue for A power 1. Here lambda 1 is 2. 2 power 2 plus 2, it is 6. For lambda 2 is 3, what is B? 3 square plus 3, 12. For lambda 3 minus 1, what is B? Minus 1 square minus 1, 0. To find determinant of B, we know very well it is nothing but product of eigenvalue. For lambda 1 2, eigenvalue for B is 6. For lambda 2 3, eigenvalue for B is 12. For lambda 3 minus 1, eigenvalue of B is 0. Product of eigenvalues of B is nothing but determinant B. 6 into 12 into 0, answer is 0. For this problem, first option is the correct option. The last problem for this video, tenth sum. The problem number 10, a real symmetric matrix is positive definite if and only all its eigenvalues are. This is straight away from the definition of positive definite. If a matrix which is with the real symmetric matrix is said to be positive definite, all its eigenvalues must be positive. Direct result, direct definition of positive definite. Today in this video I have solved 10 problems from KSET 2013 Mathematical Science question paper. I will upload more problems from KSET 2013. Already I have uploaded one video consists of 10 problems. This is part 2 of KSET. Subscribe my channel, share my channel to your friend and like my channel. Thank you.